Good morning, all participants. Should we start, Professor Monty?
Yes.
Yeah, okay. So just let me introduce you. Thank you. Dear participant, good morning. Uh, it's really it's a pleasure for us, and we are very thankful to Professor Raju Monty. He is accomplished professor at the University of Texas. We are really privileged to have him for our program, and I hope you will be benefiting with his presence here. Uh, just to read brief about him, he is a senior member of MNIT. He received a bachelor's degree in electrical engineering from Visa University of Agriculture and Technology, Bhubaneswar, 1995. Master's degree in System Science and Automation from IIC Bangalore, and PhD degree in Computer Science and Engineering from University of South Florida, Tampa, from US, in 2003. He is a professor in the University of Massachusetts currently. His research interests are into smart electronic systems, which have been funded by National Science Foundation, Semiconductor Research Corporation (SRC), US Air Force, IUSSTF, and Mission Innovation. He has authored more than 350 research articles, books, and invented field patents. His details are text in 36. I-10 is on with approximately 6,000 citations. He introduced the security system in 2004 with built-in security features designed using hardware-assisted security or security design principle, which I think he is He is widely credited as a designer for the first digital architecture in 2004 and first look at the architecture comparisons. He is a recipient of 12 Best People Awards, Fulbright Special Award in 2020, IEEE Consumer Electronics Society Outstanding Service Award, also in 2020, and IEEE Computer Science Technical Committee of USL Distinguished Leadership Award in 2023, and praise EIS the Best Textbook in Digital Science and Mathematics category in 2016. He has delivered 9 keynotes and served on 5 panels at various international conferences. He has been selected to the independent board of several Indian international panels, including prestigious IEEE Transaction and Electronics, which is currently still the IEEE Transaction and Electronics. He has integrated chief of IEEE Consumer Electronics Policy as of now. He has been serving on the board of Malaviya Consumer Electronics Society and has served as the chair of technical committee of the IEEE Computer Society during 2014 4 years. He is founding steering committee chair for IEEE International Symposium on Smart Electronic Systems, which is held in India. The 12 papers series Alex and Computers, you may kindly see that. Steering committee vice chair of IEEE Symposium, IS website. Steering committee vice chair of OITS, International Conference on Functional Methodology. He has mentored 2 postdoctoral researchers, supervised more than 12 PhD research, 26 MS thesis, and 10 undergraduate projects. Again, thank you, Professor Mohanty, for being with us and for your kind support. I hand over to you, sir. Yes.
Yes, sir, it is visible, sir.
Yes, sir.
Okay, very good. Yeah. So let me go to the full screen mode. Okay. So good morning, everybody, and thank you for this opportunity. And I hope all of you find this talk useful to advance your research. So what we will talk about here today is healthcare cyber physical system, or what I call as H-CPS. And there are hundreds of slides I will go over, and after the end of discussion, we can have question answer and so on. So what we'll cover here today, a little bit about traditional healthcare to smart healthcare, what we are and we are progressing, what direction. We'll discuss some aspects of when we say smart healthcare, what are the ingredients and what are the characteristics. We'll have some discussion on what makes a smart healthcare possible, what are the components, what are the architectures, some specific examples we'll see, what are the challenges we'll see, and some conclusion and future directions. Healthcare to smart healthcare. All of you are aware of our body, which is essentially electrical, mechanical, and biological. All this combination, these are all subsystems, and it's a complex system, of course. And altogether, human body is a entity which is very difficult to model. And how do we define health? Is the state of overall system. Okay, our physical, mental, and other things that together constitute what we call health. And in a traditional, we go to the doctor, okay, we go to a different specialist, we deal with the health insurance, we deal with the pharmacy. All these, as a patient, independently has to deal with so many what we can call as stakeholders. Okay, so which is specifically when a person is living alone without family support and community support, then he needs to, in a traditional healthcare system, deal with so many stakeholders, which is a difficult task. Now, telemedicine, all of you are now getting to know the importance of telemedicine, particularly because of current pandemic outbreak. I myself have been using telemedicine when I consult my doctor and specialist. So this is a significant thing that happened I think I would say a couple of decades ago. Now it is in this pandemic scenario much more, importance of is much more prominent. Now, from healthcare, we talked about a little bit telemedicine. Then electronic health came into picture because we wanted to have all our records, whatever, in mechanism that our doctor and the insurance company, all these can have access to. And we don't have to, as a patient, don't have to deal with a lot of paperwork when we go to the doctor. So electronic health started. Then connected health is a significant improvement of that. That is telemedicine plus electronic health and connected health. So in the connected health, the stakeholders like the laboratories, or primary care practitioner PCP, or main doctor, specialist, hospital, all these are connected together. And what is the advantage here? Again, I see that as a significant advantage. 5 years ago, when I was going to doctor, the PCP used to prescribe me. I used to take a printout, then go to the pharmacy to get the medicine. Now, what happens, because these are connected, the technician who takes X-ray and other things sends the report directly to the doctor. Doctor sends electronically everything to the pharmaceutical, and I go to the pharmacy, take my medicine, and come back. And similarly, the insurance agency is also connected. So all the stakeholders are very well connected. As a result, as a patient, we don't have to deal with these independently, and then do not have to hand carry all these things from one place to another. Now, this is because of smartphone, mobile health thing came a significant practice now. Last couple of years, this is getting very much importance. Because mobile phone has some sensors, and at the same time, we can have additional sensors to monitor, starting from blood pressure to oxygen and other things. And as a result, mobile phone has all the data that we want to monitor our day-to-day health activity. So mobile health is significant advancement from the traditional health. Then altogether, what we discussed from traditional telemedicine, connected health, then electronic health, mobile health, all together encompasses, and at the end, what we get is a smart health, or S-health, some people call it, smart healthcare we got. And smart healthcare is not necessarily what we just discussed, but in addition, lot of sensors that come into effect in the form of wearables, in the form of implantables. So those are essentially coming to picture. As a result, we get smart healthcare, which is a bigger umbrella covering connected health, mobile health, all these things. And what is additional characteristic along with all those, that this is with the patient or with the user 24/7. Okay, so that is the evolution of traditional health to smart health. And smart health, we can say, depending on the usage, okay, is being used for healthy living. For example, on a daily basis, we use different wearables to take care of our health records. So let's say starting from very minimal, like we are able to maintain our tracking things. So for example, how many steps I walked or did I sleep well, all these things. Food monitoring we are able to do. Then some aspect of home care, that is people those are living with nursing home and so on, they are getting some advantage because of some smart healthcare. And additional thing, the third aspect is called acute health. In that also, smart healthcare eventually going to be helpful quite a bit. And this is a bigger market, and a lot of researchers, including me, are working. Okay, this is in fact because of pandemic, people are now realizing how taking care of your own health and having some idea like whether I'm doing well in terms of my health trend or the other things are important. And this combination of internet, then internet of things, whatever we call in a specific case here, we call as internet of medical things. So smart healthcare is coming out of the internet of medical things and other components. So in terms of smart healthcare characteristics, so what we call as smart healthcare, we have seen some slides now. So we can define like this. It's a conventional healthcare with a lot of body sensors which are connected to the body as implantable, wearable, and so on. Then certain smart technology like mobile phone and so on are coming to the picture, like also tracking devices and so on. Then information and communication technology, they're always connected. For example, my wearable is connected to my smartphone through Bluetooth, or phone and other things are connected to Wi-Fi, to internet, and so on. Then machine learning is a big part of it. Okay, we have all this data coming from the sensors. So smart healthcare won't be effective unless we make some information, retrieve some information out of the data, sensor data that we get. So these things are together well defined using what is called Internet of Medical Things, which is a specific instance of Internet of Things or Internet of Health Things. And then when we big picture of all these things we add, sensor, then a lot of data, then data retrieval and so on, modeling and so on, it becomes what we call healthcare cyber physical system. So sensors, IoT, specific cases IoT, then AI, then all these electronic health record, all these things together makes healthcare cyber physical system or smart healthcare. In a specific architecture, like a lot of people try to model the smart healthcare or healthcare cyber physical system, this is a 4-layer architecture. Some researchers have proposed. And in one layer, the body area network, okay, which consists of implantables and wearable and so on. Then user interface layer, okay, then a black box, which is essentially a model, machine learning models, modeling different data, healthcare data specifically, and then remote access by physicians and by emergency unit and so on. So that's a 4-layer architecture of smart healthcare or healthcare cyber physical system. We can see from one end user to the doctor in this IoT-based H-CPS model, where what we are able to get in the help of H-CPS patient-specific context, okay, and his or her records and so on. Then we are able to provide some level of evidence based on the local intelligence and so on. Then all the patients wearable and so on, and his mobile phone and so on, all these are connected to the internet, and as a result he is able to get access to all the data, his own data, as well as the PCP, the physician is able to access all those data. So they are essentially through the internet talking to each other. So patient is providing the data as well as aware of his or her health situations. So as the doctor. And a specific type of example which is getting very much importance is the wearable medical devices. Without device, without sensor, there is no smart healthcare. So fitness trackers are everybody is using, and this is a seizure detection watch, which is a watch based on the physiological data and so on. It's able to detect whether somebody is going to get seizure and notify the emergency health providers. And then this insulin pump, which is getting a lot of attention. Those who have serious diabetic problems, okay, they can have automatic insulin. And then embedded skin patches can provide some sort of automatic data, healthcare data sensing from the body. And after wearable, implantable also getting important. And here I bring to your attention pill camera, for example, this camera can somebody can sell like a tablet, and that camera goes and takes a picture of the intestine completely, and doctor then make assessment of the health of the intestine. So that's a interesting invention. And another brain pacemaker is another implantable where people with the seizure and other things can basically be controlled. And then other implantable, which are drug delivery system MEMS devices, can also be part of the implantable system. So altogether, we have wearable and implantable. Now, some researchers characterize the smart healthcare with 7 Ps, they call it: participatory, persuasive, preventive, perpetual, programmable, and predictive. So that means here participatory means the user or the patient, himself or herself, is part of the healthcare process. Okay, he is participating with the doctor for taking care of his or her health. And important aspect I always like out of the all these things, 7 Ps is called personalization. I like the personalized aspect very much in the smart healthcare, because here you are getting personalized attention from the PCP, because the unique connection between the patient and the doctor happens as a result of this one-to-one sensor data and PC participation along with the patient. So the 7 Ps are very important that smart healthcare is able to provide, which traditional healthcare doesn't provide. Preventive is also very important. Smart healthcare can predict what things may go wrong. Then one who is alert can take preventive measures to avoid the healthcare issues that he or she may get in future. Similarly, predictive, based on your data that you are getting every day, physiological data and so on, predict what health problems that you may get. So these are 7 Ps. And perpetual, it's there with you all the time, because you are wearing the wearables or implantable. So then in the smart healthcare, once we have those systems in place, sensors and connectivity and so on, we can take care of the daily health. We can also take care of the clinical health. So in the daily health, we can have diagnosis and so on. Then we can think about some preventions, fitness checkup, activity, emotional analysis, all these things we can do. Then we can have certain daily treatments. Okay, that is some level of therapy we can do, some level of status monitoring and so on. Then in a bigger picture, clinical healthcare, there physician can intervene, and physician can do some medication and so on based on the healthcare data. And in terms of advantages and disadvantages, okay, advantage, it's definitely user is getting a lot of advantage. Real-time intervention is possible. For example, somebody gets some heart problem or seizure, epileptic seizure. Okay, those attention one can get. Then service providers can get advantage. Manufacturer also can get advantage in terms of standardization, compatibility aspects. But there are a lot of limitations as of now. That's why is our research area. Okay, security aspect, lack of standardization of smart healthcare, communication. For example, whether Bluetooth will work for the smart healthcare better, or Zigbee or Wi-Fi. Okay, then data integration. All these are there, and that's why we are working. That's why this is important field for research. So, so sensors, as we see, we told a few minutes ago, this is a perpetual smart healthcare. Sensors are always connected to each other and all the time. That may consume a lot of battery life, as well as may have some privacy aspects. Okay, and then data analytics needs to happen, and how the device will connect to the cloud, and as well as edge and so on. Those are important aspects that smart healthcare has, and also they themselves are problems, because these challenges need to overcome. We need to solve them. That's why these are there. And due to these reasons, we need to have a lot of optimization that we'll discuss later on. And in terms of the components, so what makes a smart healthcare as a smart healthcare? This is the picture that we can see, that we have seen, but I put it in a little bit different way. So we have wearables, and we have different online data or offline data also if possible. And then these are the doctor saint, okay, who is taking care of our data and entering some way. And overall, all this data is stored in the cloud in the form of electronic health record, which has those privacy, security, and other aspects that we may see later on. And so overall, as IoT is a specific example of Internet of Things with biosensor, glucose sensor, and so on, which are medical sensors essentially, and then different data and so on. So sensors are very important. Human body has a lot of, we discussed, this is a electromechanical and a biosystem. So so not a single sensor that is just what you can say that can cover everything. No, it needs tons of sensors, as you can see, like EEG, for example. ECG is different, then oximeter is different, even thermal sensor, thermometer is different, and gyroscope, accelerometer, all these variety of sensors we need if you want to maintain all the health record that we want to have, so that we can monitor our quality of health. So, and these are all different sensing devices, variety of sensors, and they are when they're connected, they have their own battery life and other issues that we solve. That is why, there is no way that all of these one person can wear all the time. So, selected of the sensors we can use at a time, and then other sensor can be used and depending on the need. And then coming to the other component after sensor, important is the connectivity. Because of this connectivity, we have smart healthcare. So Bluetooth is one technology which is reasonable power consuming, 10 milliwatt kind of power, as you can see, transmission power. And Zigbee is another, then like medical implant communication device, that is another. So these are different communication, and people say that is when I work with other researchers, it's not that easy to communicate when a device is implanted. Okay, like human body has its own set of resistance and so on. So Bluetooth I have heard does well, so as Wi-Fi. Those two I have heard, and others like may be working, but these are possibilities. That's why this is important research challenge. That is how it communicates through our skin and so on. But at the same time, does it consume a lot of power so that it can stay for a long time in our body? Then another component is the electronic health. This is very significant. A lot of times I have seen, like I live with, I mean, I go to India a few months in a year. I stay here more or less around 10 months. So I see the different worlds every year. So I see, like my parents, for example, in India, they go to the doctor with their paper record. Okay, they have a paper record of everything. They carry that. Whereas when I'm here, I don't carry anything with me when I go to the doctor. So that is the difference. So electronics record, a health record has played a significant role to make things easier for the patient, and for the data to be accessible by various hospital in the network, okay, where our insurance works, okay, and so this is a significant component I consider. Of course, associated to this, a lot of other issues come, that is privacy and other things, but those can be handled as a research problem. And after the healthcare record, important aspect is the data. Okay, we get the data. Okay, and data needs to be analyzed, because with a lot of data we are lost. Okay, what do we do with those data? So from the data we need to retrieve some sort of information. Let's say, for example, I have glucose level data, or my EKG data or EEG data. From that data, what is my conclusion? Okay, what do I say, whether I'm doing well or I'm not doing well? So those analytics has to happen, and we can then say about our health assessment, how good or bad our different data are. So these are important components of the smart healthcare as well, data analytics part. And data analytics can happen nicely and accurately if we have very good machine learning model. So machine learning model, now all of you are familiar, that is how important it is in any of the smart system that we can think of. So various kind of models, okay, what is more appropriate for what kind of data, those are important problems, and that has to be part of the smart healthcare system as well. So again, these are research field, and we can work on various type of models to cover various type of data. We know now from our sensors that so much so many variety of data here, EEG to ECG, then oximeter, pulse sensor, all these variety of data are there, and maybe many more. And how do we cover with the different variety of models? Those are different research that people are working, and we have done some as well. Then another important component I'm seeing that is going to be part of smart healthcare as well, that I see is a brain-computer interface that is going to come, and it's not just because of trivial problem that people know, like to how to handle brain, mental health, and so on. But beyond that, that is how with BCI we can do something that people are not able to do right now. For example, if a paralytic patient can use the BCI to do a lot of things on his own instead of being dependent. For example, here we have one example operating his or own wheelchair. Then right sides he or him see essentially watching a movie, controlling the TV channel, and so on. All these things. So this is another important component I see, and variety of ways BCI can happen. People are working. I have some examples here. Then another thing, virtual reality is future, part of smart healthcare that I envision. Why? For two reasons I see here. One is surgery. For example, like doctors can do better surgery if they can have virtual reality available to, so that the small portions that they cannot easily reach for surgery, they can have better view through virtual reality and can do better surgery. Then also I'm seeing virtual reality can be used in therapy. For example, PTSD, that is post-traumatic stress disorder, that is a serious problem, health problem, a lot of people have, and virtual reality can do some therapy towards that. So that is another smart healthcare component I'm seeing for future. And crowdsourcing is important. We just talked, that is data, then data models, and based on those models, how to predict whether we are doing well or not doing well in terms of our health. So crowdsourcing is important aspect. What is that? How that is important? For example, suppose we want to know in a specific city, let us say how many patients are there with a specific disease. Let us say, for example, allergy is a very simple thing. Okay, how many people have pollen allergy in the city? How many people have like other dust allergy or something in the city? So those data, and how then you are doing as an individual with respect to the city health, those things we can get if we have crowdsourcing and more data, people volunteer giving data, so that we can make assessment of that. For example, in the pandemic situation, we can some extent think crowdsourcing is important aspect. How it is? Suppose we want to monitor how many people are having COVID-19 problems. Okay, so infections, those crowdsourcing also can voluntarily allow people to give some sort of data. Then we kind of keep track. Okay, that is what essentially is the certain extent is the contact tracing. Okay, that is where the COVID-19 patients are. Anyway, so that's the important component I see for the smart healthcare system. Anyway, so here I'm going to discuss some specific smart healthcare examples. Problems are, so variety of problems are there, starting from simple stress to heart disease and other things. So I will discuss few things that I feel are important. Okay, and we are doing. So those examples are there. So stress, I think, is an important problem. It's rather a simpler problem, a lot of people say, but it is affecting a lot more population. Okay, rather some people say more the urbanization, that means more and more people living in urban area and more city life and more what people call as advanced places, they have more rather stress. Okay, so what is estimated, that is a major economy like for example US, India and other places, 6 in 10 workers experience workplace stress. Okay, which is significant. 60% people have stress. Then in US, 75% adults have stress-related problem. Australia, 91% adults. And as a result of all these things, there are a lot of negative aspects. Depression is one important negative aspect out of all those. And what is observed, a lot of people get depressed because of work stress. And however, 75% of those do not have medical or healthcare, what you can say, help to cure those. So that is why I felt stress we should do. And we have done a lot of work on this. I will be discussing few. And stress can be good stress, bad stress. Okay, and a body reacts to the stress. That is the important aspect, and as a result, we feel weak and so on. That we'll see. So it's basically some sort of external things happening, and as a result, body is reacting to it because we have secretion of cortisol is a hormone, and then adrenal. Those are secreted, and if this happens quite often, we have lack of energy, and we may get diabetes and other things, and mental health and so on. So this is one we need to address, and we have been trying, and this is our vision. What is my vision? Two of my PhD students have worked on this. One did a certain work, another current student is putting a lot of emphasis on this. This will be our PhD. So what is the idea here? How we can monitor stress from different physiological as well as other signals, and then we do some sort of analysis. Then we want to give certain advisory for a long term as well as short term, so that the person will not basically will recover. That's the big idea. So people are trying to have stress consumer devices are also there, but they do not explicitly do the stress. What I have listed here, Empatica, Garmin, all these, they can provide some signals which we need to monitor and then do machine learning model and so on to decide the stress level and so on. But these are available, but these are not explicitly providing stress data. So we have done 2-3 works. Here one, we want to accurately model and rapidly detect the stress level with physiological data. One we called stress lysis. So this one, we monitor the body temperature, then particularly sweat is important. So that means we envision one person who are having stress will wear a band, and that band will take sweat and other things, which is basically with the help of a humidity sensor and so on. And then we analyze with machine learning model, then we decide what level of stress is there. That's one work we did. And we prototype that's working very well as we get information that is roughly as far as I remember more than 90%, I think 90%, 90%, something like that was the is the accuracy level here. Then this is another interesting work we did with how we can correlate sleeping parameters with stress. That is another work, we call it smart pillow. We started that work, then that further developed to what we call pillow. We'll discuss later. And here I list what are the sleeping tracker devices we have right now. That is Fitbit is tracking, and this is Nokia Sleep, and all these things are there. Muse is there. But all these have different type of drawbacks, and this sleep tracker not necessarily are giving us the stress data. So we worked on this, that's why called smart pillow, where we are keeping track of the sleeping habit and then classifying them low, medium, medium high, and so on as 5 different levels of stress. And that smart pillow work has evolved to a bigger domain, what we call a smart yoga pillow or Sayo pillow, okay, where we are analyzing different patterns of the sleep. Period one, somebody is just starting sleep, then trying to sleep. All these things we are able to monitor, and then accurately say how long somebody slept and what is the stress level after correlating this with the physiological and other data. So specifically, snoring range, respiration rate, heart rate, all these we are able to model and then come up with certain numbers. Based on that, we are able to declare whether low stress, medium stress, and so on. So we model smart pillow as one device with a certain physiological approach, and we are able to accurately classify 5 levels of stress. And that evolved to, as I was mentioning, with the machine learning model approach, and with 96% accuracy, we are able to declare the stress level. And at the same time, we have the data that we are keeping in a secure way with the blockchain that we may discuss later on. Another work, this I like more, that is, okay, I keep telling the students, okay, you go able to detect stress, so what? So this is the answer. Okay, once we detect stress, we need to advise the user what to do with it. So I want to come up with some answer. What are the short-term remedies? What are long-term remedies? That is what I want to do. So I feel is one work that's under review. So we are monitoring all the things that we can. In fact, we have also able to take into account food consumption and so on aspects. Then we are able to classify what level of stress, and then we are able to suggest what to do: physical exercise, yoga, then breathing exercise, and so on. So so what we define as a short-term remedies, long-term remedy, two different types of remedies we want to prescribe, and depending on the level of stress and so on. And as a result, the user can take care of himself or herself. And we have fully prototyped this, I feel, is with open access information and public information. And we have designed very nice user interface also that clearly tells what is that problem and what is the short-term remedy or long-term remedy, I feel is. And other aspect that food is very important. Okay, food, like if you have good food, balanced diet, then our health is taken care of. That is an important aspect. So we handle that, and then I was doing a little bit reading. That is how important is the diet. Okay, diet I saw is very important. Okay, so in 2017 data, what I found 11 million deaths related to the food, and they quantify that 255 million disability adjusted life years, they call it DALYs, okay, were attributed to the bad food habit. And bad food habit can have psychiatric disorder, chronic the health, heart aspects, the high blood pressure and obesity and so on, malnutrition and all these things can happen, diabetes as well. So I was doing a little bit reading of what are the commercially available. There are a lot of apps, as you can see. Rather, we found around 25 apps. All of them have some sort of weakness. Rather, I would say these are mostly manual entry of data, mostly, and some automatic are there, but they are not a complete solution. For example, nutrition values and so on, they are not able to provide. So anyway, so when we classify those, whatever available, okay, manual, if you are healthy and you can do manual job, it will do a lot of accurate data. That means you manually enter all the information to your mobile phone and it does the calculation and so on for you. But what we want is automatic, because a lot of people, those who are not doing well in terms of health, they will not do manual job. Rather, we want to do certain or facilitate their healthcare by doing something automatic. And automatic process, a variety of things are available. Hand and mouth movement, one can keep track to see what and somebody ate. Then we can weight the food and decide how much food consumption and so on. Then food image processing. So food image processing with computer vision approach has a lot of promise to do the diet intake quantification and management. So this is one work we started, iLog we call it. So iLog is a work where food we are automatically quantifying. Okay, for example, a plate. Somebody brings a plate of food, and this system automatically tells identifies what is the rice, how much is the rice, and first is what are the food on the plate, then how much is the food consumed. All these things, then it has a nutrition database. It quantifies automatically what is the, after identification it quantifies. So then so somebody knows when he or she ate, okay, what was the calorie intake. So this is the architecture of that. So we have classification, and then with feature extraction and classification, we are able to automatically identify what are the food, and then we have a nutrition database, and we are automatically quantify what is the calorie intake from that. And then there is a very nice mobile app design. So this mobile app displays what is the food intake, and this system is doing excellent. It has a 98% accuracy. So with this iLog, what did we do? We automatically quantified what we ate and what is the calorie. But that is not the end of story. I want to also give the user that what should be his or her next meal. And we did that work as a bigger picture. So this is what I call diet prediction. So first aspect is what is called diet intake, that means what we ate and what are those food, and then how much the calorie. Next thing is the diet prediction. Okay, we consume this much food, this is your calorie intake, what should be your next diet so that the health is good. So this is a more difficult work rather. And one student had done this, we call this a smart log, where we are modeling this, that is what somebody ate, and then based on the health condition and so on, okay, what should be the next diet. So that the meal is balanced and the calorie intake is in a level where the user will not have obesity and other type of health issues. And this we have modeled, prototyped, and this is doing very well as well in terms of accuracy, 98.6% accuracy here. Another, these two students have actually done PhD in this work with me, on epileptic seizure. This is an important problem, and it's abnormal activity in the nervous system. As a result, the patient is unconscious and loses control over himself or herself. And here, this is again an important problem. Up to 1% of world population suffers from epilepsy. And this is an important neural disorder after stroke, Alzheimer, and so on. That is happening. And then there are serious aspects called SUDEP and so on, which can happen because of the epileptic. So when I was doing a survey of things, so that is how we can detect seizure. Then comes the control aspect again. So EEG is something that people are putting a lot of emphasis because this is more accurate. And then one can analyze those in time domain, frequency domain, wavelet domain data, but non-EEG also important aspect that I see, because you cannot have a smart watch-like device with EEG kind of signal analysis. Anyway, so non-EEG based method, as I see, I don't see are highly accurate, but there are a lot of effort. People are trying. That is with accelerometer data, blood pressure data, all these things, how we can come up with an approach so that we don't have to do EEG based, then we can have more wearable and so on. Okay, EEG based needs something that has to be connected to the head as a cap or as a hat. Okay. Anyway, so this important problem is also evident from the fact that is IBM has a True North chip. This is a relatively recent work where they have, as far as I know, is around 10 years of EEG data they have modeled, and they are able to, that's why, detect seizure very accurately. That is their claim. And here another types of consumer electronic device, as you see, is a smartwatch, which is not obviously based on EEG data, but it is able to detect seizure. That is this just came 2 years ago, and people are trying. And what we have been trying is to address some drawbacks that people have. We see that seizure detection latency is very high, and most of them are not suitable for IOMT deployment, and intervention mechanism, that is control, is lacking. So this is one past student who started working. So what he did is detecting seizure, okay, that is an important aspect, very fast. And then we are able to integrate a drug delivery system so that the drug delivery happens in a reasonable time to control the seizure right away. And if we compare the problem of detection, that is most of the detections are in few seconds. We are trying to do what we call early detection in the range of 1 to 2 seconds, and we will be very happy if we can do seizure prediction, which is a more difficult problem because there are a lot of medical uncertainties in the seizure prediction. That means before happens, how to predict. So that is a difficult problem. So one student worked on what we call as here as a neurodetect, where we did a DW based that we discrete wavelet domain, and we did here picture extraction of DW data. Then we did the detection, and we have two different computing paradigms, and cloud computing paradigms, and still this is more than here cloud computing 2.5 seconds, and this is to 1.4 seconds, and we have been working, and we have further developed better methods to do that. So this is the method once neurodetect work, we have DW domain, and we extract the features, and we train a DNN model, and overall this is doing in the range of 1.4 to 2.5 depending on how the computation And another work we did, this I like very much, so that is to model the seizure more accurately. And we have used a model, kriging we call, which not many people are using actually. That's why we try to explore it. And what is the beauty of it? That it can capture the correlations, spatial correlation in particular, that can happen in EEG. Okay, thus in the brain, the signal can originate from many sources. How we can capture those so that we can much more accurately detect seizure. That is the key idea. And we, this our hypothesis has been proven to working well. Okay, we are able to detect seizure in less than 1 second and very accurately. So this is in this detection approach, we have to do signal denoising. Then we can do either wavelet domain or in time domain. Then certain feature extraction, sorry, host parameter is one approach. Then fractal dimension is another approach like that. And then kriging can be used as a classifier as well as for modeling and so on, that we'll see later on. So kriging classifier, when we used, we have done quite well. If you see, this is doing in less than 1 second, 0.85 to be particular. And so once we detect seizure, okay, we need to control it, and various control mechanisms are available. Okay, this is the doctor job, that is to do the drugs and surgery, and then therapy, deep brain stimulation, and other things people are doing. Then here, focal drug delivery is something that we try to model. I work with medical schools to come up with drug delivery approach which can potentially implanted. So that is the idea. When we need drug delivery, when none of these are working essentially, and this is obviously for the serious seizure patients. So the idea here is this, that means a device that will be here, which will detect and which will have drug reservoir, and with catheter, the drug will go to the brain. So that's the idea of the overall system. And we evaluated some pumps. Okay, this is a magnetic pumps, and then this is a piezoelectric pump. So two variety of pumps we have evaluated and prototyped. And then we have also explored, if instead of one reservoir, we have multiple reservoir, two reservoir. These two reservoirs can have different types of drugs. Maybe one is less severe, another is more severe, or it can also carry two same drugs, but can be a fault tolerant approach. If one reservoir doesn't work, second reservoir can potentially work. So like that, we are multi-reservoir pump. Also, we have been modeling and to explore how they can be effective in the overall drug delivery system. So piezoelectric has its own advantage, disadvantage, and this electromagnetic also has its own advantage, disadvantage. So both are potentially useful. And other aspect we have been working on, one student, what we call fall detection. This we feel is a very, again, important problem. Approximately a third of elderly population of 65 older have some fall, okay, and a lot of hospital admission happens as a result of that. So we want to model it. So fall detection, there are some wearables available. Okay, that is Apple Watch can do, Philips Lifeline and other things can do fall detection, but they have their own set of problems. So we want to do better than that, of course. And as a result, we have been trying to model, okay, like right now fall detection works take more time, and prediction, they don't do prediction, they do detection only. That means after somebody falls, then only they say, okay, you fell down. So what we're trying to do, that is with how we can come up with a wearable, okay, that can detect and predict fault for elder, taking physiological as well as visual signals. So that is what we're trying to do. So we presented one work, what we call as Good Eye. Okay, this system takes care of this is visual data, that means somebody's activities, and then this is physiological data, different sensors. And we do overall, what it does is a multimodal essentially signal processing, and then accurately able to predict fall did not happen or fall going to happen, that means predict. So sit down, that is the, or fall occurred, and then notify the emergency units like that. So we do the, so this is basically the idea, that is how the camera we use to capture images, and then from the coordinates we decide whether somebody fell down and so on, or we can basically predict somebody is going to fall and warn accordingly. We have prototyped it as well, and with heart rate sensor, accelerometer, and then this is a camera. Okay, altogether this is visual signal, this is physical physiological signal, and this is doing 95 with 95% accuracy in the detection and prediction. And this is like one very important work I want to bring to your attention. This is essentially Amit Joshi and his group has done MNIT and have been helping, and this is I encourage him to continue doing, because this has a lot of impact in India as well as outside world. So what is the estimation? You can see here huge number, 700 million population has diabetes. Okay, that's all the things I just discussed: stress, food habit, seizure. Okay, all these fall all together. Okay, is less than whatever problem that you are seeing. Diabetes is a global crisis. Okay, so this is important problem we need to address. So in the traditional way, that is like invasive approach. Okay, and this is what non-traditional approach. That is what we have been trying. Okay, I have been helping MNIT to do that, and it has a lot of potential. And what it does, you don't have to take blood sample. Very simple. Okay, that is a significant problem. Okay, continuously taking blood samples to measure, and it has its own downside, infection to other things, and non-invasive. Okay, you will not find many products right now in the market. Israel, I see some one or two. I see advertisements. Okay, but this is a very important market that we can do impact for India and a global scale. The idea is this. Okay, right now some PPG-based sensors are available. They are not greatly accurate. We are near infrared-based mechanism we are doing, and as a result, we are able to provide a highly accurate glucose level. Okay, and big picture of this will be part of healthcare cyber physical system, as you saw. Okay, where we will be monitoring, and where the way exactly I mentioned drug delivery in the EEG and the seizure related stuff you saw. Okay, similarly, so here we will be monitoring the glucose level, non-invasive. Okay, like a simple ring on the finger, or a ear ring, or some kind of mechanism, and then the data stored gets stored here in the blockchain kind of mechanism, or physical on-cloud function like security we have mechanism, and then securely the insulin pump is injecting some level of, for serious diabetic, some level of insulin. Okay. Anyway, so they have done in the MNIT this development, very interesting, and we have serious success in terms of, as of now, publication and patent. And this device is prototype, and estimated cost is in the range of $20. Accuracy claimed is 100%. Okay, so which is very good. And then another version of this is what we call iGlu 2.0, where we have further more accurate models developed, starting from in the previous one we started with capillary glucose, and we have serum glucose, which is much more accurate device. And another idea in terms of healthcare, like advocate, that is whether we can help visually impaired. Okay, even similarly, hearing impaired is another problem. I see a lot of elderly population have hearing issues. Okay, but visual also there for many younger as well as aged population. So this is important problem I advocate people to work on. And also another thing, as mentioning heart related, which we have not done, but that is also another important problem that can have global impact. We have a lot of challenges in smart healthcare system. Okay, and important part is user is a part of the smart healthcare system. That is important in the sense user is participating in the healthcare, but that is also a negative side. Then user is compromising its his or her privacy and secret mechanism, personal privacy, locational privacy, and so on. So it's a what you can say, double-edged sword, what people call. We are part of it, at the same time face the problem. So anyway, so that this needs to be addressed. Okay, so, and when we go to the details of what are the requirements, okay, all the devices, connectivity, other things we are using have to low power, higher efficiency, small form factor, interoperability, continuously connected. As a result, there are a lot of power, and then this has to be handled. Then high speed, security and privacy. Device needs to be secure, data needs to be kept private. So data is very important in the smart healthcare, quality of data. Okay, if we do not have good quality of data, we cannot make any judgment whether a specific therapy will work, or even in a current case whether a vaccination will work, or all these things. They are all dependent on data. So quality of data is very important. Okay, so that we can make better judgment on anything, any therapy or any medicine or anything. And machine learning, the models which play, I mean, we get the data and we, based on the data, we make model and then we make decisions. Those are not easy. Okay, very difficult problems are there. Okay, machine learning have their own downside in terms of energy requirement, in terms of compressor requirement, and so on. And then people can introduce wrong data there, fake data, and so on. So all these have to be addressed as well. And I always bring this to attention when you talk about machine learning. It's not just machine learning, also the machine learning model, how they will run after the model is built. Those are also important problem. One is the training aspect, the prediction aspect. Both need a hardware resource. So if you have very complex model, probably they won't run in a device like wearable, okay, which do not have much horsepower. So we need to have training which has to be with minimal resource uses, minimal energy uses. At the same time, we need to have model which will run in a reasonable device. So those two important aspects are there. And the deep neural network, other things when we say, it's not straightforward. It's quite energy consuming as a resource consuming, well, and we know. There's a security challenge when you go to the details. Data aspects, data eavesdropping, data confidentiality, all this can happen, location, and all these details. And at the same time, device security is also a very important aspect of smart healthcare. For example, your Fitbit is hacked or your insulin pump is hacked. Those are also serious problems. So it's not just the privacy that is somebody's health record is compromised. That's okay. That's a bad problem, but it's not that hazardous or a serious problem compared to a device security, as you will see. So, but people pay attention, okay, in terms of privacy, what US agency predicts, that is data is stolen, okay, 55% times, and data is compromised by hackers and so on. So all these things happening, which are privacy issues and so on. And in the healthcare sector, okay, depending on the life cycle data, that means data starts from a user and then it goes to doctor, then hospital, then a cloud, and goes to different stakeholder. As a result, the level of where the data can be compromised varies from one place to another. But device security is what important that I have in this slide. That is, let's say you have insulin pump, or you have a pacemaker, or you have a implantable in your brain. All these, if they are connected to the internet, which is what happening, okay, right now, even the pacemakers are connected to the internet. Okay, those are serious health issues. Okay, compared to as you just said, healthcare. This is healthcare data. So this device security is much more serious. Somebody can compromise the or drains the battery, or compromises the insulin level that should go to the body. Those can have serious health implication. So here is an example that is like impersonate attack, radio attack. All this can happen, and somebody can control the doses of insulin pump. Okay, or somebody can control basically trigger wrong reading to the device. And pacemaker particularly can drain the battery of the pacemaker. All these things can have serious problems. And so as a result, if we see a big picture of implantable and wearable devices, so IWMDs, okay, like pacemaker or insulin pump is wearable, pacemaker is implantable. So all these together can have serious security threats and can have serious health implications. For example, if a battery gets drained, you want to let's say replace the pacemaker. That is a serious surgery process, which is a life-threatening surgery. So that is why IoT device security I consider as a very hard problem compared to the data privacy and so on. And this is another important point that I wanted to bring to attention. That is, in the smart healthcare, when we have a lot of data, lot of records are there, sometimes the records may get exchanged. Okay, like one user data can be by mistake. So it happens. Wrong prescription, wrong medical, other things are happening time to time in the health medical sector. So how to ensure that all the medical record are correctly tied up to different patients. So that's why signal authentication is an important aspect that one can think of solving. Then I see ethics is an important aspect in smart healthcare. Now, user is practically or directly part of the process. It's his or her health at the same time. The doctors and internet, all these have access. So how we maintain, meaning when we have smart healthcare instead of traditional healthcare, so ethics aspects are well maintained. That's an important aspect. Then safety. So when we have different things implanted, okay, pacemaker and so on, okay, and so how it is ensured that the implantable or the wearable are not causing bodily harms, okay, for example, different reaction and so on. So safety is also important aspect of smart healthcare. And some solutions of security and so on. Okay, so it's a big trade-off that I saw many times. Okay, that is energy and so on. Okay, that has to be handled. And depending on this, from healthcare point of view, for a rapid solution, for example, stress monitoring or EEG based seizure monitoring and so on. Okay, a lot of computation should happen at the home. For example, we have to have some computation happening in a mobile phone, some computation happening even in our home router. Okay, so more and more I am inclined to believe that is computing paradigm is a better computing paradigm for the smart healthcare, because your computation happening close to the user, so then decisions can taken and the user can be better solved in terms of his or her health crisis. Machine learning model I was mentioning as important problem. Okay, that is the time taken for the model development and time taken for the execution of the model for inference. So hierarchical machine learning, for example, one idea we developed what we call bootstrapping. One idea we developed where we take a lot of data, but we don't use all of them. If we know that is the model data has a lot of correlation and so on, then for example, we can develop one initial model and then the data, new samples we can generate from the model instead of taking the old data. And as a result, we can do much better, much faster modeling and so on. So this is one idea we proposed, where initially, if we know the user data has a lot of correlation, then we can develop use models initially called which capture the correlation. For example, in this case, kriging we are using initially. Then from kriging, we are training a DNA, deep neural network model. So this is the model as a result is very fast and also lightweight, and also we are able to develop the model with minimal data. So we developed that model and we have done the comparison, and we see that that is doing very well. Here attaining close to 100% accuracy with very minimal samples. Okay, and training time, as you can see, has reduced significantly compared to the only DNA model and so on. And machine learning point of view, distributed machine learning, that is what Google is trying, what is called federated learning. Okay, that is another aspect that is people are here I mentioned about hierarchical approach, and here distributed approach, where with the different user we have some models, we develop some model, and then we continuously refine those model through federated learning or collaborative learning. And this is Google's idea that they are trying. Okay, and here we came up basically our own instance, that where we said, okay, with the each data which have a lot of correlation, we develop a kriging model basically on 1 by nth of the sample of the data, and then we train the neural network model, which we call a distributed kriging bootstrap modeling approach, and this is doing quite well. Okay, so as you can see here, we have different portion of the data developed at different computers or different cores, and then those models are aggregated, and then this is training the neural network, same neural network. And overall, the model that we get here as a result is very accurate, at the same time lightweight to run. So we can see here distributed queuing DNN compared to the original only DNN. Okay, it's much faster, and training time is 9% of the original training time. That is the observation from the EASE data that we have. And when we compare, as a result of this, DNN with the queuing DNN, distributed queuing DNN, so latency-wise, model execution taking same time, but training has reduced significantly, as you can see here from this plot. Security is a very important problem, okay, and we have developed POP-based security. Why specifically POP-based security? Because POP has energy consumption point of view excellent. It's a small hardware add-on to the overall hardware, and as a result, the energy consumptions are very low, and we are able to provide effective solutions. So this is an idea we proposed, okay, that is we integrate POP, which consumes some microwatts of power, but very unique solution. That is here, okay, 200 microwatt of energy overhead, power overhead, and it is doing authentication in seconds of time. So we have validated, and it is working well. And another challenges point of view, healthcare data, that privacy is important. People are trying blockchain-based solutions. We also have some attempts. A blockchain-based solution can potentially give more security, can have better sharing and so on, and that is what the prediction. So people are trying, and we have been working on this in our SIOPILO project. In the SIOPILO, we have blockchain that is storing the data, and here each person has one blockchain. Let's say in a family, we have 5 pillows, then there are 5 blockchains stored, so that everybody's data stays in a blockchain. And then let us say for this SIOPILO, if it goes to market, let's say there are 100 million population using the SIOPILO, then we have 100 blockchains, so that is keeping each one of the data secure way. That's the idea here. And then this sensor point of view, we have discussed this. We use here sleeping habit and so on. Physiological data also can be integrated, all these things here. Okay, and we can have very good prediction of sleeping habit, then stress level, and we can also basically suggest, okay, how to do stress remedy and so on. But all the data, important aspect here we focused is stored in a blockchain and having right access and so on to the data. So this is the blockchain that we proposed. So these are various stakeholders there, okay, then user, doctor, and so on, technician, and so on, different stakeholders. And we propose this in this one. This is Ethereum blockchain with smart contract, and laser is here. And it's that overall data. When I told my student that is, let's say, you build a SIOPILO and people are buying, let's say 10 million people are buying, okay, where you store that data. So we have to store the data in offline approach, okay, we have to have a certain distributed database, okay, there are IFPS and so on, those databases are there where you can store the data. And then there has to be some encryption, decryption mechanism, okay, and so on, so that the data is stored. So overall, we have fully implemented this, and we did a very nice user interface. So this is how the Ethereum and the data is stored in database, distributed database. And we are, so this user interface shows, okay, different heart rate, respiration rate, and so on, all these things, activities, and then the sleeping and other computations it is doing for the user. So that's overall fully prototyped SIOPILO work, and I invite all of you to see in my website. All these are there. You can see this is 38-page overall thing we have presented. Complete details are there. So with this, so what we can say, we have launched healthcare cyber physical system, and which is smart healthcare, and this is made up of Internet of Medical Things. And smart healthcare, what is the plan here? Our vision is essentially to give a personalized healthcare with a reduced cost and continuous, what you can say, or perpetual health monitoring. It has a certain advantage, as you can see here, but at the same time, security and privacy issues, all these things are there because user is a participant. Okay, and machine learning model for the healthcare domain needs a lot of work. Okay, and the people are working, and this will happen further as well. And security of particular implantable devices are serious concerns, as a lot of FDA warnings have been given. And integration of blockchain and so on. Okay, it's not straightforward. Blockchain was not meant to do that, and in fact, we wrote an article in IEEE Computer Magazine. It came last issue. That is, what are the challenges if blockchain is used for the healthcare applications? So we acknowledge all the support that we have received for this work. And I thank you for listening to my talk, and I'll be happy to take any questions. And these slides are available in my website. You can go and download. Thank you. Any questions?
Just participants, if you have any question, then you can raise your hand. We can take it one by one. Okay.
Good morning, sir. Rajiv Monti, sir. I am Chitrakant Sahu.
Hi.
Hello, sir. Good morning.
Yes, I listen. Good morning.
Sir, nowadays, one more term is using mixed reality kind of thing. I just saw some video from the Geo. They are going to launch 5G, and there are some Geo glass. Inside, they are saying that they have used mixed reality instead of a augmented reality or so.
Okay.
Yeah. So, can you, sir, just give the brief idea about what will be the mixed reality and what will be the future in this direction?
So, no, exactly mixed reality in what context they are using, I'm not fully aware. Okay, but virtual reality and augmented reality, those I know. Okay, so they might be using the terminology just to have a marketing term. Okay, so virtual reality and augmented, all these basically from there are two ways people are thinking of using. One is particular I mentioned PTSD. That is post trauma, that is that stress disorder. Okay, that is a significant problem actually. There are a lot of, particularly as you can see, like every country has significant military, right, where they go for where all border protection and so on, right? So it seems military people and also a lot of people in their life, when something very serious happens, okay, that trauma, that stays in the mind. Okay, so that comes to their mind from time to time, and that PTSD problem is very serious problem. So virtual reality is considered as a therapy. That means what let's say scenery you need to see, what kind of action you need to see, so that it will cool down your brain. Basically, that's the idea. Okay. And another application I'm seeing, that I have only seen 2-3 papers on that. In fact, in our magazine, I published 1 or 2 articles. That is how doctors can use virtual reality to do surgery in a better way. Okay, so let's say some miniature things like inside brain and so on, or even eye surgery. Somebody is seeing very small thing and they are not able to properly visualize. Then, if a virtual reality environment can do a environment where doctors will have better vision to see what the surgery they are doing. Okay. So that is another application. And your original question, as I remember, is mixed reality. So that, as I said, they might be using this in a different way as a
not in, sir, healthcare. I saw their video. They are saying that some are in online mode, like physical person is online mode, and some 3D image from the some other person who was not able to join meeting. So because of that, something
so those
kind
are
of
actually that I've seen. That is actually that. In fact, 20 sometime in TV. Actually, I forgot. Some election time, there is a TV broadcast where they first time demonstrated how with a holographic technique. Okay. They can have a news reader. Okay, virtually present. Okay, that's holographic technique. So that, in fact, my vision is this. This is very interesting discussion, that people are talking about 3D TV, right? 3D technology. What is that they're using? They use a glass, right? That glass, and that 3D vision has a negative impact on the brain. Whether you know or not, if your brain doesn't accommodate that glass and the way right now 3D technology, you get a headache.
Okay, that might be the problem. Okay.
So that's why holographic can be better technology. That is what my vision compared to the traditional 3D now we are seeing. Okay.
Okay.
Anyway, okay.
Okay.
Thank
Thank you,
you.
sir.
So
Let
some,
us ask the
sure,
questions.
sure.
So, okay.
Somebody Aniruddha. Okay. Can
Hello.
yes.
I think
Sir.
Amit sir, you just read the questions from the audience.
I think we can take it one by one. I think Aniruddha has raised the question. Please,
Right.
Aniruddha,
Right.
go ahead. Go ahead.
Yes, sir. My question is like, can you comment on the problem of over-diagnosing a patient using all of these smart technologies? Because there comes to be a point where, like any small aberration from the data will be seen as something that needs to be investigated, and that will lead to the patient encountering like substantial monetary problems due to
Right.
like investigating those things, and then they will be under constant stress due to these problems that keep on appearing, but
Right.
they will not be like major problems, they will be just minor or benign problems. So
Right. So
won't
this is
using smart technologies lead to that problem like
yes,
that
that is an excellent question. Okay, I agree with that. Okay, sometimes it can have, it's like we are overdoing. Okay, so that is why this needs to come under two aspects. One is ethical aspect. Okay, that is whether the data that we get and the corresponding quality healthcare we are providing, they are consistent or not. Okay, so it's like false alarm, right? Somebody doesn't have a
yes,
problem, but you are predicting as a problem. Then he goes to the treatment, he spends all the money. Okay,
yes,
so that is one ethical aspect there. Okay, that's why I remember I only spent one slide on ethics aspect, but it comes there. Okay,
yes,
so ethics of smart healthcare. Then another way also I'm thinking that is our model. Okay, we develop. See, these are what is smart. Smart comes from the data model, right? We have good
yes,
data and we develop good model. As a result, we get smart. That is what it is. Okay,
yes,
so those models need to be trained very well, okay, with much more clear data, so that it is not what you get false positive is not doing as well as false negative it is not doing. So that is why when we do model validation, we have to measure the precision, recall, F1 score, accuracy, sensitivity, whatever, all these parameters. Okay, so we need to avoid false positive as well as false negative. So those in that direction it will come. But at the same time, what I have observed that is right now we are seeing right pandemic, right? Can you
yes,
trust any data that we see? We cannot trust. Some are over reporting, some are under reporting. That is going. So medical, maybe health science has that problem, and that is instead of a so it's way more data driven. Okay, so that is
yes,
what so it comes and how accurately present. That's why I'm taking two things. One is the modeling aspect, but before that the ethics aspect. Somebody should not report wrong data.
yes, sir.
Okay, and then you are completely screwing up the model, and then that triggers. Okay,
Yes,
anyway, it's very good question, excellent question. Thank you.
yes, sir. Okay, sir.
Sure. Anybody else has any questions? Somebody said, please share your website. Okay, so my website is www.smohntY.org. Very simple. Okay.
Now, sir, actually, I had one more question.
Sure, sure.
Imagine if a startup that wants to get into producing medical devices, what are the first steps that they need to take such that they ensure that their designs are in compliance with whatever regulatory body is there?
Sure. Okay, very good question. So in fact, that is what I keep pushing. Who is that? Amit. That I tell, doing a startup or a product is a passion. It is not just science and engineering. Okay. So in
Yes,
fact, I in IEEE, so IEEE has given me a lot of very good outlook. I communicate with a lot of people. So I work with some people who are only interested in startups. Okay. So what they tell me, what is important is not the science and technology only, whether the product has a demand in the market. then only somebody will show interest, okay, to invest something, okay. So
Yes, sir.
let us say, that's why I was saying glucometer has very significant importance, okay, even heart related, okay, and now like COVID-19 thing you are seeing, so many things can which are related to flu and other things will also have market, okay, and diet other things are also there. So first is there is a, whether there is a demand for that product, that is important. Then you accordingly would go, you do the research. Then once the research happens, patenting is very important. Okay, you
Okay.
have the idea, you definitely do the patent before you talk to other people. Otherwise, people will say they because a lot of publications are in public domain. What is the guarantee whether you did that or somebody else did that? That comes very significant in terms of commercialization. So patenting. Once you develop the research and your prototype is ready, patented. That is important. Then clinical trial is important step. Okay, clinical trial in India relatively easy, but some reason like I don't know, like I'm seeing in the current situation, clinical trial unless we do through proper channel. For example, clinicaltrials.gov is a website. If you see globally, whatever clinical trials are going on, it is monitored. Then people will value yes. But if you do and don't do clinicaltrials.gov procedures, okay, nobody will trust your data that you really have done clinical trial of whatever you are building. Okay,
Okay.
so there are some people actually in the US. I know there are small companies who are helping to do the clinical trial. Of course, they charge money. Okay, and in India, maybe you will get volunteers relatively easily. Okay, and then those volunteers, but as I said, globally to get importance, you need to go through clinicaltrials.gov. Okay, because I'm actually, as a, I do, whether you know, I myself like a lot of Ayurvedic medicines. I do. I go to India 2 times in a year, so I do go to Ayurvedic therapist. We don't call them doctors here in US. We call them therapists. Okay. The reason always consider why the let's say Ayurvedic medicine works. Okay. Then you do the clinical trials through the clinicaltrial.gov. Then globally they know that these medicines were tested with this many patients and this is the result.
Yes,
Okay,
sir.
so that is very important, so which Ayurvedic people are not doing. Okay, and as a result, even though some medicines are working, they are not acceptable. And in fact, homeopathy medicine in US, when it is sold, it is written as a statutory warning. The way in cigarette, it's written cigarette smoking is injurious to health. Here, similarly written, these are not approved medications. Okay, so that's why so they are not doing clinical trials. So important point as your question was for commercialization,
Yes,
right?
sir.
So one is patent is important. Second, clinical trials following global procedure.
Yes,
Okay,
sir.
that it works. Okay, and clinicaltrials.gov is a very good website. You can go and see there anything going on global trial. It's there. These are public domain data. Then only people will trust. Yes, this
Yes,
device works. Okay.
yes, sir.
Anyway, thank you.
One more
Sure,
point is
sure.
like
Mhm.
if we make like a wearable device which will monitor maybe like the hemoglobin levels or the oxygen levels in the blood,
Mhm.
like what is the most important thing that we need to consider such that like that we can make this into a device which will be used by doctors and other things like
Okay. So there are two things. So you doctor and user they are not same. So what you can say type of audience for you. You are the person who wants to build, right?
yes,
So your target is more towards user or more towards doctor. That is a very tricky thing because user point of view, user wants to wear something that is convenient.
yes, sir.
Okay. Let's say you put I myself know, like for example, when I was using my current this wearable, okay, I'm happy the recent one, but before that, every 3 months that belt was breaking. Okay, band
Yes,
was breaking. So I was as a user, I was not happy. Okay, so for user, it's convenience and the band or whatever wearable not reacting to the skin. That is important.
okay,
Okay,
sir.
but for a doctor, accuracy is important.
Yes, sir.
Okay, so that is depending on whom you are trying to make happy or you are trying to address, the things will differ. Okay,
Okay.
but in general, you need to address all of them so that it sells. Otherwise, if your device is not accurate, why somebody will buy it?
Yes,
Okay,
sir.
so like that. Okay. Anyway, thank you. Any
Uh,
other questions?
that's all.
Anybody? Thank you.
Uh, sir,
Yes.
Mohanty sir.
Yes.
Okay. So, sir, I have one question. Sir, we are applying a smart healthcare technology for a successfully treatment of the few of the disease very
Right.
well, and it is I think at a success also. But sometimes, sir, it happens that in some of the disease, whatever we provide the prevention, then that is act as a temporary one because some diseases may have appear after a few weeks or days again. So
Right.
what could be the smart healthcare solution that we can apply that we whatever the solution is being applicable, maybe it is through maybe online telemedicine or maybe through offline that is having a better result than just to providing a temporary solution.
Right. So do I understand the question? Like, let's say the disease symptoms change or something, okay, or smart healthcare as a preventive approach versus a treatment approach. I didn't get the question pure. Meaning, do you want to say whether smart healthcare can be used for preventive? That is your objective?
That is exactly the thing that whatever the solution or maybe sir it is not applicable to only smart healthcare but maybe for a normal visit also that in a some
Mhm.
of the cases what happens that whatever the treatment that I am getting that may not be exist for a permanently because few disease has a tendency to appear again after
Right.
sometimes.
Mhm.
Okay. So probably in a means medical term we are using that emergency ED visit. Okay. So
Right.
ED return. So that is ED return is some of the cases are means higher for a few disease. So can we
Right.
have a some smart healthcare solution that actually help us in this particular cause?
Right. That is what I was kind of giving a what you can say formal what you can say name to it. That is how smart care healthcare can be used for preventive if we think that direction. Okay, but it's a very difficult problem. Okay, for example, right now COVID-19, let us say, right? Some people are saying those who got it, there is no guarantee that they will not get again. Okay, they got it, they got cured, they may again get, right? So that is so that problem is a very difficult problem. Okay, but even traditional healthcare is not easily able to solve, but smart healthcare for preventive that direction, if you pay attention, there probably there is some solution. That is that means because we have a lot of data for the user, okay, which we have continuous access. Okay, which let's say traditional healthcare point of view, do we have somebody's data for 10 years at a time in hand? We do not, meaning the doctor cannot see all the data, 10 years of data at a time. Okay, so whereas in the smart healthcare, because we have the EHR in the access, okay, we can completely see the whole history of the person. Okay, what potential problems he had or he may have, complete historic things. So smart healthcare in that respect, because the whole medical history can have access. And then I remember doctors do ask, okay, for example, let's say heart type of problem or diabetes problem, they typically ask whether your parents had it, other maternal or paternal, those grandparents had those history they want to know. So in this respect, I'm thinking that smart healthcare can do a better job in completely taking the history into account and do better prediction and so on. But I understand the question. Like repeatedly, suppose one disease comes back to one person. Okay, so how that will be addressed? That is a very, as I said, it's a difficult problem. But in the smart healthcare, that can be easier. The reason being, a doctor has a lot more data to judge somebody's health condition much more accurately than a traditional case where we cannot explore all 10 years of health record of somebody, which we can do in smart healthcare.
Okay, thank you, sir.
Okay, sure.
I think if there is no further
Sure.
question,
Okay, so
then
anybody interested to stay in touch, do send me email. Okay, I will reply if any questions or anything or more feedbacks on anything. Just send me an email. Okay, I'll be happy to reply. Okay, thank you all.
Thank you very
Okay.
much, sir.
Sure.
thank you, sir.
Sure, thank you.